NASA and Elon Musk have one thing in common, and that is colonizing Mars. Despite Musk's best efforts, his company's pace is lower than NASA's. This is due to the fact that NASA has made a huge discovery on Mars, which will have a significant impact on his plans for mass colonization. So what exactly has the space agency found on Mars? Will Musk's plans change because of NASA's findings? Come with us as we investigate the recent NASA finding on Mars that will alter Musk's strategy. According to the adage, the great minds think alike. The top minds in NASA and SpaceX are working toward the same goal, landing humans on Mars. However, the two organizations are operating on different timescales and have different time horizons. While NASA plans to send 2 astronauts to Mars in the 2030s, Musk would like to send many more people to Mars as soon as humanly possible. Musk, on the other hand, would do well to take note of NASA's most recent Martian discoveries, as they bear directly on his own endeavors. NASA has put in a lot of time and money studying Mars because it's such an intriguing planet. Space Exploration Technologies Corporation has sent 5 Mars rovers to the Red Planet: the Sojourner, Spirit, Opportunity, Curiosity, and Perseverance. This has increased our understanding of Earth, but as NASA's rovers have progressed in sophistication, it has become clear that much remains to be discovered. Curiosity and Perseverance are the only 2 NASA rovers still in operation, out of the original 5. A pair of Chinese victors both go by the name Zhurong. Insufficient resources prevent NASA from sending a human to Mars at this time. This is due to the fact that it lacks the technology to bring astronauts back home and does not have the answers to the problems astronauts will face on the planet, such as high radiation levels, gravity issues, a long journey there, and many others. NASA can send rovers to Mars without putting any lives in danger or spending a lot of money. As part of NASA's Mars Science Laboratory (MSL) mission, Curiosity touched down on the Red Planet in 2012. The rover remains the largest rover ever constructed. Curiosity is 10 feet, 3 meters long, 7 feet or 2.2 meters tall, and 2.7 meters or 9 feet wide. Despite its diminutive appearance in photographs, it is roughly the same size as a typical SUV. Since its 2012 launch, Curiosity has been exploring Mars' surface, and in that time, it has traveled more than 16.8 miles or 27.4 kilometers at speed of up to 100 feet per hour. Curiosity, in contrast to its predecessors, which used solar panels, has a radioisotope power system that generates electricity from the heat of plutonium's radioactive decay. Selfies taken with the rover are top-notch. The primary objective of the Curiosity rover's mission on Mars is to collect data that will help scientists decide whether or not the Red Planet ever hosted microbial life. Curiosity has been very productive in this regard, uncovering a wealth of new information about Mars that is changing scientists' perspectives on the Red Planet. Mars may be too cold for life now, but scientists think that it may have been more like Earth's climate billions of years ago. Water in its liquid state is essential for life as we know it, and back then there was plenty of it pouring into rivers and oceans. Scientists believe organic carbon and similar substances could have provided sustenance for life on Mars. How, then, has our natural tendency toward inquisitiveness aided our search for Martian life? So far as we know, carbon is essential for life, and the presence of a significant carbon signature in an environment such as Mars may indicate the presence of biological activity. The presence of life indicates the presence of carbon. However, carbon comes in a variety of forms. While all carbon's atoms contain 6 protons, their neutron counts are more flexible. All forms of carbon with varying numbers of neutrons are collectively known as isotopes of carbon. Carbon-12, 13, and 14 are the 3 naturally occurring isotopes. While elements 1 and 2 are relatively stable, C14 is radioactive. In comparison to carbon-12's 4 neutrons and carbon-13's 7, carbon-14 flaunts an impressive 8 neutrons. Photosynthesis and food metabolism both rely heavily on C12, but these are not the only places in which this isotope of carbon is used in living things. Since C12 lacks a single neutron compared to C13, it forms fewer chemical bonds when combined, with other atoms to form molecules. I'm confused as to why we're even bringing up carbon isotopes. The reason for this is the discovery made in the Gale crater. Since 2012, Curiosity has been operating in Mars' Gale crater. Sediment at the lake's base, formed from the physical and chemical weathering of volcanic rocks, is just one of the many reasons scientists study the Gale crater in search of life. There are low acidity chemical energy sources and non-carbon elements like oxygen, nitrogen, and sulfur found there. The rover has taken a powdered rock sample from the crater and stored it in its onboard chemistry lab. Sampling and Analysis Facility on Mars, SAM, is the lab's official acronym. So tell me, what goes in SAM? For this purpose, Curiosity makes use of pyrolysis to decompose a sample and produce methane. For cleanliness purposes, the pyrolysis is performed in a stream of inert helium. After that, it uses a tunable laser spectrometer to determine which carbon isotopes are present in the methane. The Curiosity team analyzed 24 rocks and made a monumental discovery. C12-C13 ratios were elevated in 6 samples. The ratio of C12 to C13 in the Gale crater sample was significantly different from what is found on Earth, by more than 70 parts per thousand. Almost all of the carbon on Earth is in the form of C12, while only 1.07% is found in C13. It would be very exciting to find these results on Earth, as it would indicate that C12 was produced by a biological process. So here's how it goes down. Bacteria living near Earth's surface produced methane many years ago. Methanogens are prokaryotes belonging to the archaea domain. Hot springs, oxygen-depleted wetlands, and ruminant digestive systems are just a few samples of places on Earth where methanogens persist. Methane is produced by these bacteria, and when it escapes into the atmosphere, it is oxidized by the sun's UV rays. However, the molecules that rain down to Earth's surface as a result of these interactions are more complex. Once they reach the surface, their carbon footprints are captured in the rock forever. Curiosity's discovery in the Gale crater on Mars could be easily explained if the same thing happened there. One of the competing theories for what the Curiosity rover discovered in Gale crater is a molecular cloud hypothesis. The theory proposes that millions of years ago, the solar system moved through a molecular cloud. Evidence suggests that this occurs about once every 100 million years, despite how rare it is. Hydrogen molecules make up most molecular clouds, but this particular cloud may have contained a higher concentration of the form of carbon discovered by Gale and Curiosity. As a result of this cloud, Mars would have cooled significantly, and glaciation would have prevented the molecular cloud from combining with the rest of the carbon on Mars. The concentration of C12 would have increased instead. Still, the molecular cloud theory bears further investigation despite its low probability. Exposure to UV rays is a secondary factor. According to this theory, the rover 95% carbon dioxide in Mars' atmosphere interacted with UV light to create new carbon-containing molecules. The rain on Mars would have brought these molecules down to the ground, where they could be absorbed by rocks. This method has some parallels to methanogenesis, which you may have encountered. This one is similar, but there aren't any living things involved. Researchers on Mars are analyzing the planet's carbon cycle in an effort to determine which of the 3 hypotheses is most likely correct. Scientists will have a better opportunity to study Martian rocks once a sample is collected by NASA's other rover, Perseverance, arrive on Earth. And Curiosity will continue to study rock samples and measure the carbon isotopes, wherever the source of the carbon isotope Curiosity detected may be. If Musk were involved, he would be interested in the outcome. Musk is interested in science, but not for traditional reasons. He's making preparations to move to Mars. Musk advocates for long-term Martian settlement. A population of up to 1.1 million people will be resettled by him there. Musk is leading the development of a new Starship rocket with Mars colonization as its primary objective. Several components of the 2-stage rocket will aid Musk in his mission. For instance, it can be reused indefinitely, which will drastically cut down on the pace of space travel. Numerous tons of supplies must be transported from Earth to Mars, so this issue is of great financial significance. Starships use fuel that, in theory, could be produced on Mars. That way, the Starship can return to Earth with plenty of fuel. With the completion of Starship being crucial to Musk's plan to send the first humans to Mars by the decade's middle, the SpaceX team is under constant pressure to meet the deadline. Funding for the project will come in part of SpaceX Starlink satellite internet subsidiary. The conditions on Mars, however, are so extreme that Musk will need to terraform the planet before his colonists can call it home. The plan is to make Mars just as habitable as Earth, to solve the problem of Mars not having an atmosphere to protect humans. Musk has proposed nuking the poles. Musk proposes using nuclear missiles to blast the Martian poles, where he believes artificial suns could generate enough heat to create an atmosphere similar to Earth. Musk displayed a photo of Mars after terraforming in the SpaceX headquarters lobby in Texas, and once that happens, the only technology humans would need to survive on Mars would be breathing machines. What are your thoughts on this? Do you think Musk and NASA will succeed with their plans on Mars? Write down your thoughts in the comment section below, and if you like this video, consider subscribing to the channel and don't forget to click the notification bell for more updates about Mars. That is all for today, and we'll see you in the next video.